Hello, this is day 1 of chapter 14, which is called Refraction. In this chapter, what we will look at is how light behaves as it goes from one media to another. We'll also be looking at how light travels through a lens. So those are the topics will be covered in this section. So let's get started. The first one, start with a warm-up. In this warm-up, they ask you guys, how is a rainbow and a mirage related to each other? The answer to that is, they both have to do with bending light. Alright, so our lesson objective for our first day of chapter 14 says students will be able to solve problems using Snell's equation. Alright, so let's start with what is Snell's equation. Snell's equation is the path of light is bent as it crosses a boundary between two media due to refraction. Alright, first of all, what's a media? A media is what light is traveling through. It might be lights traveling through water, might be lights traveling through air. So that's the media we're talking about. So those are two different mediums. Alright, now in this picture you'll see that the straw is bent this way, slightly different than the one on top, and this one completely different. Why do they look different? Well, I would say that one probably has water, the other one has something other than water. Maybe it could be alcohol. So each substance gives you a different index of refraction. Alright, now how light bends. Light bends towards the normal as it goes from air to glass. Or light bends away from the normal as it goes from glass back to air. Alright, let's talk about first of all what is normal. So in this picture we have air and water. So picture that there's water here, air on the top. Normal is a perpendicular line. It's an imaginary perpendicular line that is 90 degrees from the boundary between the air and the water. Here, my red arrow represents light, and this light will go into from the air into the water, and what happens then is rather than continue a straight path, it's going to go ahead and bend. For air going to water, it's going to go ahead and bend towards the normal. And the reason why it bends towards the normal is because this one slows down light more than air. On the other hand, what if the light's coming out of the water? What it will do then, instead of going in a straight path, it will bend once again, but this time it bends away from the normal, giving you a bigger angle here as opposed to here. So from air to water, it'll bend towards the normal, and from water to air, it'll bend away from the normal. Alright, now let's take a look at the equation for Snell's law. Snell's law is a fairly simple equation. N1 times sine theta 1 is equal to N2 times sine theta 2. The N is a constant that depends on the substance, not the angles. Alright, that is referred to as the index of refraction. So if it's something like air, the substance that light's traveling through is going to have a very small value of N, the index of refraction. But if it's like water, it's going to have a larger value of index of refraction because the water will slow down the light. So the thicker the material, the more light slows down, that will give you a higher index of refraction. Alright, our next table is going to go ahead and show the index of refraction for a yellow light, which has a wavelength of 589 nanometers. And let's see. The medium is the substance that the light's traveling through. It could be a vacuum, air, water, or ethanol. Here, crown glass, quartz, flake glass, or a diamond. And the N, these are their values. In a vacuum, the value for the index of refraction is 1. In air, it's just about 1. It's 1.0003. For our calculations, we'll just use 1. But now water, you'll see that it starts to get a little bit bigger. 1.33, 1.36 for ethanol, 1.52 for crown glass, quartz is 1.54, flake glass is 1.6, and finally a diamond is going to go ahead and give you 2.46, which is higher than all the other ones. Alright, so let's get to our first problem. In our first problem it says, a light ray of wavelength 589 nanometers travels through air, strikes a smooth, flat slab of crown glass at an angle of 30 degrees to the normal. Find the angle of refraction. So they want the light's coming in, it hits it, it bends. What's the new angle? It comes in at 30. By the way, this yellow light, 589 nanometers, the 589 wavelength, we don't use it for the problem. We don't need it. Alright, so let's go ahead and get to work. Our formula, one more time, it was N1 multiplied times sine of theta 1 equals N2 times sine of theta 2. Alright, so this is our incoming information and this is our outgoing. So here we're going to put all the information for the air. Here we're going to put all the information for, in this case, is crown glass. Alright, so let's start with the N. What is N? Well, let's take a moment to go back. And you see the N for air is 1.0003. We're going to round it off to just 1.0. So I'm going to substitute that right here. 1.0 multiplied times sine of the angle. From the air, it hits the boundary at 30 degrees. So that is our incident angle. 30 degrees. On the other side, it says we have crown glass. So crown glass has an N, an index of refraction of 1.52. So now I'm going to put that on the other side. 1.52. Multiply that times sine of theta 2. And theta 2 is what we're looking for. The question was, find the angle of refraction, which is on this side. It's coming out. Alright, so let's go ahead and get to work. I'm going to go ahead and in my calculator, I'm going to find this value, sine of 30. So put in my calculator, sine of 30, and it gives me 0.5. So I have 1 times 0.5. Sine of 30 is 0.5. If your calculator does not give you 0.5 for sine of 30, chances is you have it in radians instead of degrees, so switch the mode. Alright, bring this side down. Again, I'm looking for the theta 2. So what I'm going to go ahead and do is get rid of the 1.52. So I'm going to go ahead and do that by dividing what I do to one side, I got to do to the other. See, by dividing by the 1.52, now it's gone, isolating the sine of theta 2. So what's 1 times 0.5 divided by 1.52? The answer it is 0.329. Alright, you want to use at least 3 digits here. Now, all I need now is to get rid of the sine so I can have the theta 2 all by itself. Alright, so how do you get rid of a sine? Inverse sine. So I do inverse sine to both sides, so it's going to be inverse sine of 0.329. That's going to give me theta 2. So notice it's inverse sine. So the answer to this problem is 19.2 degrees. Alright, so the light came in at an angle of 30 degrees, that's an angle of incidence, and our angle of refraction will be 19.2. It moved closer to the normal. Alright, that is sample problem A out of page 492 of your textbook. Alright, next, let's go ahead and do another problem. In this problem, it's a very similar problem. They ask you guys to find the angle of refraction for a ray of light that enters a bucket of water from air at an angle of 25 degrees to the normal. Alright, no problem. This is another Snell's law question, so we're going to use the same formula. Alright, the angle of incidence, that means the angle coming in, is 25 degrees Celsius. So that's this one right here. Sine of 25. The question, once again, is they want to know what's the angle. Alright, and it's going from air into water. So let's go back to our table. For air, again, is 1.0. And water, 1.33. So that's going to go on the other side. Alright, so there you have it. Now we're going to solve for sine theta 2, much the same way. So when I go ahead and begin by getting sine of 25, that gives me 1.0 times 0.423. Bring the other side down. Next, I want to isolate the sine theta 2, so I want to get rid of the 1.33. So I divide by 1.33. That cancels it out. Gives me sine theta 2. And let's see. 1 times 0.4 0.23 divided by 1.33 gives me 0.318. Next, I'm going to go ahead and do the inverse sine so I can isolate the theta. So it's going to be inverse sine of 0.318. Answer is 18.5 degrees. Alright, so that is our second problem. Alright, next, let's move forward. Our next problem, they ask you guys for an incoming rate of light in a vacuum of wavelength 589 nanometers. Fill in the unknown values for the following table. Alright, so let's take a look. There's our table, and they want us to do three separate problems, A, B, and C. But this time they're moving around what exactly they want. In the first one, they give us the two materials, flint glass to crown glass, and the angle of incident, the I is for incident, is 25 degrees, and the angle of refraction is not given. Alright, we'll take a look at B and C in a bit. Let's take care of A. Alright, so A is similar to the two previous problems we've done. Alright, so our angle of incidence coming in is 25, so I put sine of 25 degrees. But we're going from flint glass to crown glass. The values for them, let's go ahead and take a look at the table. Alright, so flint glass is 1.62, crown glass is 1.52. Alright, now again they're asking you what is theta 2. So very similar problem. Alright, let's start with sine of 25. Gives me 1.62 multiplied times 0.423. Then I divide by the 1.52 to isolate the theta. That gives me 0.450. And then lastly, I'm going to do inverse sine and that will give us our answer, 26.8 degrees. Alright, so there you have it. That is part A of this problem. That is very similar to the two previous problems we've done before this one. But now, on part B, they're going to ask us for something else. They're going to ask us, what is this? Alright, we're going from air to some unknown medium. And this is the incident angle coming in. That's the refraction angle going out. So now, figure out essentially what is N2 they want. What's N2? Alright. So, N1 is air. The value of that is just 1.0. Multiply times sine of the angle coming in, 14.5 degrees. N2, that's what we don't have. And sine the angle going out, it is 0.98 degrees. Alright, so that's a problem. And now we're solving for something different. What is N2? And more importantly, they want us to identify it. Alright, so I'm going to begin by getting the sine of theta, sine of 14.5 multiplied times 1. So sine of 14.5 times 1 gives me 0.250. And on this side I'm going to do the same, sine of 9.8. That gives me 0.17. Now, I want to isolate the N2, that means get rid of the 0.17, so I do that by dividing it by itself. Give me N2 divided by 0.25 divided by 0.17 gives me 1.47. Alright, that's a value. But what is it? Let's go back to our table. 1.47. It's not listed on this table. Might be, I'm going to go ahead and look it up. and give you the answer at a later time. It's not on the table. Alright, let's move forward. Alright, now next one is from air to diamond. Alright, so they give you guys the 31.6, and again they give you guys what's missing is the angle of refraction. Very similar to the first ones we did. Alright, so for air, again, by now you should know index of refraction. You know the value of that one. It's 1, right? Multiply times the angle coming in, which is 31.6 degrees. Now it's going into a diamond. The value for diamond, 2.42. So there you go for a diamond, 2.42. And again, they're looking for theta 2. Alright, so let's start with this side. I'm going to get sine of 31.6 gives me, multiply times 1, gives me 0.524. Next, I want to go ahead and divide both sides by 2.42 so I can isolate the theta. That goes ahead and gives me 0.216. Finally, to get rid of the sine, I do inverse sine. Alright, so inverse sine goes ahead and gives us an angle of 12.5. Alright. So there's our problem. That's part A, B, and C. There's one more practice problem. We'll tackle this one. It says, a ray of light of a vacuum, wavelength 552 nanometers, traveling in air, enters a slab of transparent material. The incoming ray makes an angle of 40 degrees with the normal, and the reflected ray makes an angle of 26 degrees from the normal. Find the index of refraction of transparent material. Alright, in this case again you're solving for N2. So let's go ahead and hit it. Let's see, it's coming in from air at an angle of 40 degrees. So air is 1. And at a sine of 40 degrees. We don't know what N2 is. And the angle of refraction is 26 degrees. Alright, so in this problem we're going to go ahead and get sine 40 multiplied times 1. That gives us 0.643. And on this side, sine of 26 gives us 0.438. Next I want to isolate the n, so I'm going to go ahead and divide by 0.438, so that way it will go away. And what I do to one side I have to do to the other. That gives us 1.47. That is the index of refraction of our material. Let's see if it's on the table this time. Now it's another material that's not on the table, though I know it's somewhere between ethanol and crown glass, but there's many, this is just a few elements that are listed. There's many different mediums that have an index of refraction. Alright, last but not least, you got to review this on your own. Alright, so this is homework number 34, page 514, number 11, 12, 13, and 14. That is your assignment. Alright, good luck with it.